So I'm going to go over the answers to the EOC Benchmark 3 Part 1 pretty quickly so the video is not long. You can always pause or fast forward as you need to. So as we look at this first problem, it says, what's the cube root of all of this? So the biggest error would be to take the index 3 and divide everything by it. But you actually have to find the cube root of 729. So on your calculator, you should be putting in 3, and these are on Casio calculators, so 3, then shift, then the caret button, because that's going to bring up the X root button, and then you'll put in 729, and you'll hit execute. That's going to give you an answer of 9. So that means that C is out and A is out. And then you're going to take each of the exponents and divide those by 3. And so that gives you x squared, that's a 2, y to the 5th, and z to the 1st. And so that means that our answer would have to be B right here. Question 2. So question 2, which expression is equivalent to this trinomial plus, and that's important, it's plus this trinomial. So we are not multiplying, we are adding. So all we're going to do is take like terms and line them up with their other like terms. So this is 3x squared. Since it has an x squared, we're going to line it up with the 5x squared. The plus 10, we're going to line up with the constant negative 6. And minus 9x cubed, we're going to line up with the 6x cubed. And then we're just going to add down. So 6 minus 9 is negative 3x cubed. So based upon that, I know it can't be D. I know it can't be A. Negative 5 plus 3 is negative 2x squared. So based upon that, pretty sure it's not C. Pretty sure my answer is B. But for chuckle's sake, I'm going to go ahead and take negative 6 and add 10 to it. And it is indeed plus 4. Next page. So question 3, which best describes, and as we're going through this, you should be underlining, circling things that are important. So which best describes the product of the square root of 4 and 1/4 and y? So remember, product means multiplication problem. So they're trying to trick you a little bit here, because as you look at the answer choices, they're talking about rational versus irrational numbers. So you need to know the difference between rational versus irrational. Rational numbers are numbers that can be expressed as a fraction. So those are positive numbers, negative numbers, 0, any number that can be expressed as a fraction. So even the number 3 can be rational because 3 can be expressed as a fraction, 3 over 1. Things that are irrational are things that cannot be expressed as a fraction. For instance, any root that's not a perfect root, like the square root of 2. 2 is not a perfect square. The cube root of 2. 2 is not a perfect cube. But the square root of 4 is a perfect square because the square root of 4 is actually equal to, squeeze this in here, is equal to 2. Since 2 can be expressed as a fraction, 2 over 1, 2 is rational. Clearly 1/4 is a fraction, so it's rational. Just as an aside, other irrational numbers basically are decimals that do not end and do not have a repeat pattern. Rational numbers are decimals that do end or they have a repeat pattern. So we're going to multiply 2 times 1/4, so 2 rational numbers being multiplied. Since I'm multiplying 2 to a fraction, I'm going to put 2 over 1. And then that gives us 2 times 1 is 2. 1 times 4 is 4. You can divide both 2 and 4 by 2. So 2 divided by 2 is 1. 4 divided by 2 is 1/2. So the product of two rational numbers is 1/2. And 1/2 is also a fraction, so therefore it's rational. So the assumption is the product of two rational numbers gives you a rational number. So this one says the product is rational. That's good, that's what we want. Because the product of an irrational number, right there, we don't have an irrational number and an irrational number. So because of that, I know the answer is not A. So for B, it says the product is rational. We like that. Because the product of two non-zero, both 2 and 1/4 are not 0. Rational numbers, we already determined that they're rational, is always rational. Sounds good to me. So I believe the answer is B. Now the reason why C and D are not the answers is because they both say the product is irrational. I don't even have to read the rest of it. Because of that, the answers cannot be C and D. Okay? So then question 4. What are the zeros in this equation? So I threw this question in there because we really didn't get a chance to get to this, but if we were to take this binomial and multiply it to this binomial using either the box method or a double distribution, you would get the following trinomial. So 2x times x is 2x squared. Then you multiply 2x to 3, you get 6x. Negative 1 times x, negative 1x. That's going to give you a positive 5x. Negative 1 times 3 is negative 3. I only did that to show you that the multiplication of these two binomials is a quadratic, a trinomial, and we worked with that before Christmas. And if you recall, that was that equation gave us the graph of parabolas that opened up or down. And zeros were where these parabolas cross the x-axis. So wherever they're crossing the x-axis, where I'm putting these blue dots, those are zeros. And so we can actually find zeros algebraically. So if we take this, we set it equal to 0 because this y value here is 0. And this represents the y value. So this y value is 0 on the x-axis because there's 0 on the y-axis. And so we factored this for you already and got this form. So if you have a product that equals 0, one or both of these factors here, the 2x minus 1 and the x plus 3, one or both of them have to be 0 for the product to be 0. So what we're going to end up doing is we're going to take the 2x minus 1, we're going to set it equal to 0 to see what value of x would make it 0, and we're going to take the x plus 3 and set it equal to 0 to see what value of x would make that 0. So we're just going to use our equation solving skills as we've taught you before. Our goal is to isolate the variable term, solve for x. So I want to get that by itself, which means I want to move a minus 1. The opposite of subtracting 1 would be adding 1. What you do to one side, you must do to both sides. And so the 1's cancel. You bring down the 2x equals 1. Continuing, we still haven't gotten x by itself, so we're going to divide both sides by 2. And we end up with x equaling 1/2. Don't turn it into a decimal. Then for the second equation, we want to get the x by itself. So the opposite of adding 3 would be to subtract 3. So the 3's cancel, bring down the x. 0 minus 3 is 3. So there are two solutions. And the only answer that has x being positive 1/2 while the other x is negative 3 would be answer A. All right, so then last question on this page, question 5. So don't don't just look at a word problem and think, oh, I automatically can't do it. Oh, it's a word problem. Actually read it. This one's pretty simple. A motorist decides to fill a cylindrical gas tank. Well, that might look like this. Which single quantity will best help the motorist find the amount of gas needed? So if I am filling this tank with gas, do I need to know the area of the tank, the height of the tank, the radius of the tank, or the volume of the tank? We would need to know the volume of the tank because that's what would fill the tank. Okay, for question 6, it looks complicated, but if you start reading it and really kind of highlight the things that are important, it might make more sense as you read the answer choices. So it starts off by saying the velocity of an object thrown straight up depends on the square of its initial velocity. So things in there that I might highlight would be the velocity of an object thrown straight up depends on the square of its initial velocity. And then it goes on to say, and its distance above the earth, d, so d is the distance above the earth, and can be determined by the expression right here. So the question is, what is the meaning of 20 in the expression? Well, here's 20. So let's look at that. And as you look at 20, you want to ask yourself, what's happening to 20? It's being squared. Doesn't this mention the square of its initial velocity? So if 20 is the item being squared, shouldn't 20 be the initial velocity? So there's your answer. Answer A is the initial velocity of the object. So going on to question 7. The width of a room is 4 feet shorter than its length, and its height is 3 feet less than its length. The area of the 4 walls is larger than the sum of the areas of the floor and ceiling by 134 square feet. So this is a bit of a complicated problem, I'm not going to lie. And so I'm going to show you how I would solve it given a multiple choice answer versus how I would solve it, because you don't have enough solving skills yet to solve this all the way. So we're going to have to try to set up an equation, but we're going to walk ourselves through it. So don't forget that we are talking about areas of rectangles. So area of a rectangle is length times width. So as I look at these shapes, the first thing they mention is the width of a room is 4 feet shorter than its length. So let's just say that this is the floor of my room. So this is the floor, and of course the ceiling is parallel to the floor, and they would be identical sizes and shapes. So we have a floor and a ceiling that makes 2 rectangles. That'll become important in a minute. And it says the width of the room is 4 feet shorter than its length, right here. The one thing that we don't know is the length, but we do know that the width is 4 feet shorter than the length. So I don't know the length, so I'm going to call that L. And if the width is 4 feet shorter than L, it would be L minus 4 for that width. Okay. Then it goes on to say that the height of the room is 3 feet less than its length. So we've got 4 walls going around this floor. These 2 walls here are different sizes than these 2 walls, because this wall has a length here of L, but a height going straight up of 3 feet less than the length. So in other words, if I were to draw a picture of the wall that's coming off of this length right here, it might look like this. So here's my wall. Its dimensions are going to be L for length, but its height going straight up from the floor is going to be the length minus 3. 3 feet less than the length. And this represents 2 walls. These walls are parallel to each other. So 2 walls. Then there's going to be 2 more walls. The other 2 walls are going to be parallel to each other here. So one side of the wall is this L minus 4, and then it goes up into a height of 3 feet less than its length, L minus 3. So to draw a picture of those walls, okay, one dimension is going to be this width right here, remember. So I'm going to let that be L minus 4, and the height of that wall going straight up, L minus 3. And so this represents the remaining 2 walls. Okay, then we need to set up a formula that represents all 6 of these shapes, these rectangles. A floor and a ceiling, that's 2. 2 more walls makes 4. 2 more walls makes 6. So it says the area of the 4 walls is. So the area of the 4 walls, let's find out what that is. Remember, area is length times width. So I've got my first set of walls right here would be length times width. So L times L minus 3. So I'm going to set that up. L times L minus 3. Now remember, I have 2 walls. So I want to multiply this by 2 because this represents right here the 2 walls. This is 1 wall, length times width, and I want to double that because I've got 2 that are identical to that. So then plus my other 2 walls. So my other 2 walls are L minus 4 times L minus 3. So L minus 4 times L minus 3. And again, remember, I've got 2 of these walls as well, so I want to double that as well. So this represents my 4 walls. So this is the area right here of my 4 walls. But it says is larger than, meaning greater than. So I'm going to put in here for now a greater than is larger than the sum of the areas of the floor and the ceiling. So here's the floor and the ceiling dimensions. Remember, there's 2, floor and ceiling. So these are the dimensions. So the area there would be length times width, which is L minus 4. And again, I have 2 of those. I have a floor and a ceiling, so I want to double that as well. And it goes on to say that it's larger. These 4 walls are larger than the area of the ceiling and the floor by 134 square feet. So if you think about it, this is heavier, if you will, than this side. If I want to equal out the sides so I can set up an equation, I would have to take this 134, and if I add it to this area, now the 2 areas should be identical because this has a bigger area by 134 square feet than this. So if I add 134 square feet to this side, then they're going to be equal. So I'm going to add plus 134 square feet. If I do that, I can then erase. This is probably not going to let me erase it. Nope. So if I do that, then I can change. We're going to change it instead. I'm going to change this greater than sign to an equals to sign. As soon as I added that 134, now the 2 sides are equal. And here's the whole point of doing all this. We have been given 4 choices for length. So all you're going to do is put in everywhere that you see an L, you're going to put in 7 into your calculation. You're going to do 2 times, instead of L, you're going to put 7, parentheses, 7 minus 3 in parentheses, plus 2 times, parentheses, 7 minus 4 in parentheses, parentheses, 7 minus 3 in parentheses, and then hit equals or enters. And you're going to work one side at a time. So if I do that on my calculator, I'm going to throw it in here real quick. 2 times 7, parentheses 7 minus 3, n parentheses plus 2, parentheses 7 minus 4, n parentheses parentheses 7 minus 3, n parentheses. Make sure I have that right. Yep, enter. I get 80. So for, let me write this down. So I'm going to put the left side equals 80. And then I'm going to throw it into the right side of the equation, same way. 2 times 7 parentheses 7 minus 4 in parentheses plus 134. And that's like a huge number, 176. So clearly those are not equal. So you're going to do the same thing. So 8 can't be the answer. So you're going to throw in 11. So do the whole thing all over again. So I'm going to put in 2 times 11, parentheses 11 minus 3, in parentheses plus 2 parentheses 11 minus 4, in parentheses 11 minus 3, in parentheses, that equals 288. Equals. And then for the right side, 2 times 11, parentheses 11 minus 4, in parentheses plus 134. 288. Since the left side equals the right side, B is your answer. All right, so for question 8, we have a linear inequality is graphed here. So you just have to figure out which of these inequality statements match this graph. So to remind you about a couple things, notice that every single answer has 3/4 x minus 1. All of those are the same. The only thing that's different is the inequality sign. So here's your reminder of a couple things. We are always graphing slope-intercept form, y equals, even though it's an inequality, mx plus b. So the b right here, remember, is your y-intercept. And so notice here, the graph is crossing the y-axis at -1, which is why all of these are -1. And so the m right here represents our slope. And remember that slope, we use m for slope, and that is rise over run. So as I go from that y-intercept, notice that the coefficient in front of x in all of these is 3/4. So our rise must be 3 and our run must be 4. So if I rise up 1, 2, 3, 1, 2, 3, and I run, so there's 3, and I run 1, 2, 3, 4, that's how they got their slope of positive 3/4. So all that you really need to understand is what creates these 4 different signs. So this line right here will either be solid or dotted. So that's our first thing that we want to look at. So if we have a solid line, that will be either a greater than or equal to sign or a less than or equal to sign. So solid line right here represents a solid line underneath the inequality sign. If it is a dotted line, and a dotted line would just look like this, so I'm going to erase that part because I really don't want it to stay there, but that's what a dotted line would look like. That would give you a greater than sign or a less than sign. In other words, you would have no line underneath these inequality signs. So since we have a solid line, I know that it's one of these two. And that means that I can cancel out C and D as answer choices. I know that's not correct. Then you look at the shading. Here's my line. If I were to place a person on this line, just standing on the line, dropping them down from the north, down onto this line, I would land here. So if you think about it, the shading, if I'm in the shading's above the line. If the shading's down here and I'm not in the shading's below the line. So right now our shading is above the line. So if we have, if the shading, whoops, if I can spell shading, clearly not. Okay, so if my shading is above, then we will use greater than or equal to signs. And if my shading is below the line, then we would use less than or equal to. So we've already determined that we're not going to be using these two because we have a solid line. So it's got to be one of these. Since we are above the line, then the winner clearly has to be greater than or equal to, which gives us answer A. Answer A seems to be a lot of answers on this study guide. Interesting, but true. Next question. All right, so question 9 says, use the graph to answer the question. What is the domain of f of x? So remember, domain means x values, and we only care about where the graph is on the x-axis. So as I look left and right, will this graph eventually cover all of that? And you think about it, it will, because this graph is going to continue to get wider and wider and wider. So as my graph goes this direction, I will always have, or as I go to the left on the x-axis, I will always have this graph above me somewhere. As I go to the right on the x-axis, I will always have this graph above me. So in other words, in this particular graph, the entire x-axis is going to eventually be covered by this graph as it gets wider and wider and wider. So there are no restrictions on the domain. So the domain is going to be all real numbers. If we were talking about range, which is y, range goes up and down. So I can't turn my, let me see if I can turn my pointer. Not really. I used to be able to. They won't let me now. So, all right, let's use this one. All right, so still not going to be able to turn it, but your range goes up and down. So at the bottom down here, there's nothing. And the graph doesn't start range-wise, y value-wise, until you hit right here. This is the lowest value of the graph. So when y is 1 or less, there is no graph here. But as soon as y is 1 or greater, you're always going to have a graph. So the range is actually greater than or equal to 1, whereas the domain is all real numbers because eventually this graph is going to extend out and get bigger and bigger. So make sure that you are aware of what you're talking about, domain or range. So in this case, it's all real numbers. Then question 10, which expression is equivalent to 4a squared minus 25b squared? So these parentheses really don't mean anything, because if I take 4 times a squared, I actually get 4a squared. And negative 25 times b squared, I actually get negative 25b squared. So I really want to figure out which of these 4 multiplies to give me this. What you cannot forget with a and b is that these actually equal 5a plus 2b times 5a plus 2b. And then this one, let me change colors, this one is 2a minus 5b, 2a minus 5b. So you're going to have to multiply all 4 of these using the box method or the double distribution method until you get this one. Now if you recognize that this is the difference of 2 perfect squares, and it's a special product, that would go a whole lot quicker. In other words, notice that the same thing are in these parentheses, but you have a plus minus. Same things are in these parentheses, but you have a plus minus. If you recall that, these ones go a lot quicker, a squared minus b squared. Meaning, remember that a represents the first term in the binomial, so this whole thing, 2a, would represent a here, so you could square this, minus this whole thing squared, b represents that second term. So this is typically the most popular wrong answer because a lot of kids see these two and they just square this and put in the sign. So if you square this, 2 squared is 4, a squared is a squared, you get 4a squared. Minus, square this, 5 squared is 25, b squared is b squared. So a lot of kids think that this is the answer to this, but it's not. Let's go ahead and distribute. So 2 times 2a is 4a squared. 2 times negative 5b, 2a times negative 5b is a negative 10ab. Then negative 5a times 2a, negative 5b times 2a, I'm having issues, is also a negative 10, and alphabetically you want to put your variables a, b. And then negative 5b times negative 5b is a positive 25b squared. So if you try to combine these, you are going to get 4a squared, so that matches. But these two do not cancel out. A negative 10 and a negative 10, same sign, add and keep. You get a negative 20ab, which is a middle term. It doesn't match here. There is no middle term here. And this is a positive, not a negative. So answer B is not going to be correct, but it is the most popular answer. Same thing is going to happen with A. You're going to multiply these. You're going to get the same answers here, but instead of a minus 10ab, when you multiply 5a to 2b, you're going to get a positive 10ab for both of these. So this is going to have a middle term. So that means that A cannot be the answer. Then, as you look at these, let's go ahead and multiply these out if you don't believe that this works. So let's go ahead and distribute. Oops. I want that to go away. You probably didn't see that. So 2a times 2a gives us 4a squared. 2a times 5b gives us a positive 10ab. Then negative 5b times a 2a gives us a negative 10ab. Those are going to cancel. Negative times a positive is a negative. We want that negative sign. 5b times 5b is 25b squared. So now when we add these together, we do get these middle to cancel. And you do end up with 4a squared here, negative 25b squared here. So C does indeed become our correct answer. Next question. All right, so question 11, they are telling you that Lauren is solving an equation using these steps. So get in that habit of underlining important things. It says, which statements describe mistakes in Lauren's solution? Select all that apply. That implies that there is more than one answer. So as we look through Lauren's mistakes, let's see. I'm going to actually read these before I even look through her mistakes. So let's read this. Between the given and step 1, so given and step 1, Lauren did not distribute 4 to the second term in parentheses on the left side of the equation. So something that I might want to emphasize is that Lauren did not distribute 4 to the second term in the parentheses on the left side. So we're talking about here, we're distributing. So she did the 2x she just brought down, which is correct. 4 times x is 4x, that's correct. 4 times negative 1, she should have had right here a negative 4, and she didn't. So a lot of times I suggest that we do our work off here to the side. So 2x plus 4 times x minus 1 equals 3 times negative x plus 2. So what she should have done when distributing this 4, this part she did correct. The 4 times x she did correct. But the 4 times negative 1 should have been a negative 4. And then she didn't do anything to the right side. So I agree that this is an error that she made. She did not distribute the 4 to the second term correctly. So we definitely want to check or circle. Let's circle. We're going to circle A as one of the things that she did make a mistake with. All right, so let's move on to B. Between step 1 and 2, so here we go. Lauren did not include the minus sign in front of the x when distributing the 3 on the right side of the equation. So Lauren did not include the minus sign in front of the x when distributing the 3 on the right side. So we want to focus on the right side. So now she's going to go ahead and distribute this 3 into the parentheses from here to here. So let's see if she did that correctly. So nothing changed here on the left side, even though the negative 1's incorrect. Of course she's going to follow that through because she doesn't realize it's a mistake. But 3 times negative x. They're saying she did not include the minus sign in front of the x when distributing the 3. So 3 times negative x should be negative 3x, and she did not include that here. So she should indeed have had a negative right there, it's supposed to be in front of the 3x, and she didn't have that. So when we distribute here, it should have looked like the left side will not have changed for us. But 3 times negative x is a negative 3x. 3 times negative 2 is a negative 6. Oops, sorry, that's a positive 2. How did I rewrite that? So that should be a positive 6. Glad I caught that. All right, so then I agree that she did make this error. So answer B is also one that applies. So then let's look at C. Between step 2 and 3, so we're looking between these two steps, Lauren did not combine like terms correctly on the left side. So she did not combine like terms correctly on the left side. So let's look on the left side right here. Step 2. Like terms are terms that have the same variable string. So 2 and 4, or 2x and 4x are your like terms. And so if we were to combine these like terms correctly, 2x plus 4x is 6x. So I disagree with them. She did combine like terms correctly. So we are not going to circle C. So on ours, if we are to combine these like terms correctly, we also would get a 6x, bring down your minus 4, equals negative 3x plus 6. Okay, so let's look at D. Between step 3 and 4, so we're here, Lauren subtracted the constant term. Well, constant term would be important for you to realize. So they're saying she subtracted the constant term. You need to know what a constant term is from the right side of the equation. And they're saying instead of adding it. So they're thinking she should have added it, but she subtracted it. So let's actually see if she subtracted the constant. Well, we need to know what a constant is. So as we look at the right side, we've got a choice of 3x or 6. Constants are terms that do not change value. They are terms that do not have a variable. So 6 is the constant term, 3x is your variable term. So they're saying that she subtracted 6 from both sides. Let's see if that's correct. Minus 6, minus 6. As I look at the result here, she's actually made several mistakes. The question is, did she actually make this as a mistake? So if she subtracted 6, that would correctly cancel the 6's here. But if she subtracts 6 over here, a negative 1 minus 6 is a negative 7. She has 5. Now, she does have 5 on the wrong side of the equation. If we're on the left side here, she should have had the 5 on the left. So that's an error. The other error is in her addition. If she did indeed subtract, she would have had a negative 7. So perhaps she didn't subtract after all. Maybe she actually added. What if we added the 6 here? Well, if she added 6 on the right side, these would not cancel. She'd actually have 12. But if she added 6 to the negative 1 by mistake, a negative 1 plus 6 is actually positive 5. So most likely what she did do is add 6 to both sides, giving her this positive 5. But she knew somehow that that 5 belongs over here to the right. So she just vicariously moved it over here incorrectly to the right. So she's made 2 errors. Adding 6 and then putting the 5 on the right side. Now the question is, how do we get a 3x when there's a 6x and a 3x here? So she had to have subtracted the 3x from the right and subtracted the 3x from the left. That enables those 3x's to cancel. And then 6x minus the 3x gives you 3x. The question is, did she subtract the constant term from the right? Nope, she did not subtract the constant. She must have added. And so although that is a mistake, this is not the mistake that she made, so we cannot circle it because it's not the mistake that she made. So for our purposes, what are we going to do? So you really should be concentrating on your variable terms first, not your constants. I want to get my variable terms on one side by themselves. So because the negative 3x is smaller, that's the one we want to move. So I'm going to add 3x because that's the opposite of subtracting 3x. So a negative 3x and a positive 3x are the same, or I'm sorry, are opposites of each other. That will enable them to cancel. What we do to one side, we must do to the other. So we end up with a 9x here minus the 4 equals 6. So now that we have the x terms all on one side together, we want to get them by itself. So I want to get that 9x by itself, so it needs to stay. And I want the minus 4 to move to the right. The opposite of minus 4 is positive 4. So we're going to add a 4 to both sides. That makes those 4's cancel. And we have a 9x equals 6 plus 4 is 10. So now we are in the same spot. Okay? She doesn't have the same answer as I do with the 3x equals 5 because she's made mistakes along the way. So the last statement is E. Between step 4 and 5, Lauren divided both sides of the equation by 3 when she should have divided both sides by 5. So they are saying that she divided both sides of the equation by 3. So let's look up here. Did she divide by 3? If she divided by 3, that would correctly cancel these 3's and leave an x. 5 is not divisible by 3, and it cannot be reduced, so you would correctly leave it as 5 over 3. So she did indeed divide by 3, but she correctly divided by 3 because 3 is being multiplied to x. To get x by itself, we want to undo multiplication, which would be to divide by 3. And so she correctly divided by 3. This was not a mistake. So we can't circle it. So for our purposes here, in order to solve for x, we want to undo 9 times x by dividing both sides by 9. And then we end up with x equaling, because 10 is not divisible by 9 and we cannot reduce those, we just leave it as 10/9. That was a doozy. Next question. Oops. All right, so here we go. Let me make this bigger. Okay. So question 12. Consider the functions shown. So one function, f of x, is graphed. Here's a line. This is not graphed. So the question is, which function has a greater y-intercept? So you could graph this on your calculator underneath the graphing function by just putting the right side into the graphing menu on your calculator and graphing it. And this is what you would end up with. So I'm going to graph it quickly. pretty darn tiny. In fact, for our purposes, I'm going to make this a little bigger so I can actually graph properly on it. There. I think that should work. All right, so this graph is going to cross the y-axis at +2, and then it will have a negative slope, so down 1, 2, 3, 4, to the right 1, and down 1, 2, 3, 4, to the right 1. So it is going to look like that. Well, I didn't draw my line very straight, but that's close enough for government work. So the question is asking, and move this over so I can actually see all the questions. Okay, so the question is asking which function has a greater y-intercept? Function f of x or g of x? So the y-intercept for g of x is here at, I have no idea what I just did. Let's try this. So the g function is right here. It has a y-intercept of 2, whereas the f of x function, it has a y-intercept of -2. So the g of x y-intercept is greater than the f of x. So we are going to circle answer choice. Well, let me get that out of there. It won't go away. Hang on. Let me move this over. Because while I have the pen open, I can't actually see what I'm circling. So there we go. So answer choice B for G. All right, so let's try to make 13 a smidgy bigger. Okay. So which choice is most likely the equation of this quadratic function? The easiest way to do this is to throw these into your graphing calculator under the graphing function and see which one matches this one. I can tell you right now, if you recall very quickly, that parabolas are in the quadratic form of ax squared plus bx plus c equals y. So if a is greater than 0, meaning positive, it will open up. If a is less than 0, meaning negative, it will open down. So since this parabola opens down, I know for a fact that the coefficient of my squared term is going to be negative. So I know for a fact that it cannot be answer A because the coefficient of the x squared term is +1. It could be B because the coefficient here is -1. It cannot be C because the coefficient is positive, but it could be D. So we've narrowed our choices down to B or D. So those are the only two that I have to put in my calculator. So, and also if you think about it, if x is 0, here's x at 0. If x is 0, y is going to be 2. So that doesn't work on that. Well, let's, because of the negative. Nah, it still shouldn't matter. So if x is 0, y should be 2. That seems a little off. But I'm going to throw B and D into my calculator just to double check. You can do the same. So I'm going to throw in -x squared minus x and then plus 2. Okay, so if I put this one in my calculator, I do get this. And if you think about it, if x is 0, y is 2. I don't know where my brain was on that one. This is the y-intercept, and it sure enough is +2. Whereas if you put D in, you're going to get a slightly different looking graph. So B should be your correct answer. So I'm going to make this one a little bit bigger so we can kind of see it. All right, So which represents a function? So remember, as you look at a table of values, you're looking for the x does not repeat if it's a function. So we don't have any repeating x's here. So as far as I'm concerned, a is a function. So let's look at our graph. When we look at graphs, we want to look at our vertical line test. So if I run a vertical line anywhere through this graph, and you can see that my laser pointer is a vertical line, it is my laser pointer is touching the graph in two different places at the same time. So that is not a function. Here, as I run my laser pointer through it, it is touching the graph really two places right here, because it's touching two different parts of the graph right here. So as I go through here, I'm touching the straight part of the graph and the curve. So this is not a function. Even though this is a curve, no matter where I put my vertical line, it never touches the graph more than once. So D is a function. So your answer would be both A and D. All right, so for these, question 15, examine the relation. Is the relation a function? Remember, a relation is a list of ordered pairs. And what is the range? Range are the y values. So, is the relation a function? Look for repeating x's. -2, -2. Right there, we have x repeating here. We have x repeating here. And we have x repeating here. So is a relation a function? No. That still doesn't mean it doesn't have a range. It still has a range. So our range is all the y values. So -2, 4, 1, 0, 1, 3, and -2. We like to put that range in numerical order. And yes, part of the range repeats. That doesn't really matter for a function, but it does. So we have a choice of these two. So -2, they both have -2. Then we have a 4. This one has a 4, that one doesn't. So automatically, by process of elimination, D is our answer choice. Moving on to 16. So for this one, what is the value of the y-coordinate of the solution to this system of equations? So a couple things that they're asking. They want just the y-coordinate, and they want the solution. So the solution to a system of equations. Both of these right here happen to be lines because x and y are to the first power. So I know that my graph is going to look something like, I don't know, this, an intersection of two lines in my coordinate grid. The solution is the ordered pair right here where they intersect. So on your calculator in the graphing function, you are going to put in both of these equations. Well, the problem is that neither of these equations are solved for y. So if they're not solved for y, you can't put them into your calculator. So here's what you're going to do. We're going to solve each of these for y. So let's start with the first one. So I'm going to solve this one for y. So x minus 2y equals 1. So using our solving skills, I'm trying to get the y term by itself because I'm solving for y. So I want to keep it on the left. I want to move the positive x. So the opposite of positive x is negative x. So I'm going to subtract x from both sides. So those cancel. I get a negative 2y. Generally, we write the x term first. The negative x and the 1 are not like terms, so you cannot combine them. So we generally write the x term first. So negative x, the 1 is positive, so it's a positive 1. Still focusing on the y side, we want to get the y by itself. So to undo negative 2 times y, we want to divide by negative 2. We need to divide both sides by negative 2, which means we have to divide every term on the right side by negative 2. The negative 2's cancel and you get y equals. A negative divided by a negative is a positive. If we take the x out of the fraction and just hang it to the side, you're going to have a 1 up here. So you do end up with a positive 1 in the numerator a 2 in the denominator, and the x hanging out to the side. And then for this one, we've got positive divided by negative makes a negative. So you're going to have minus 1/2. Okay, when you put those fractions in your calculator, in the graphing function, you need to make sure that you use parentheses around your fractions. All right, so then we're going to solve the other equation right here for y as well. So we have x plus 4y is equal to 7. So we are going to try to get the y term by itself. So the opposite of x, like before, is negative x. So that will enable the x's to cancel, bring down the 4y equals. The negative x and the 7 are not like terms, so they cannot combine. The x term gets written first, so negative x plus 7. We need to solve for y, so to undo 4y, we divide by 4. Everything gets divided by 4. Again, another lovely answer this is going to turn out to be. The 4's cancel and you get y equals. We have a negative divided by a positive, so we're going to have a negative. Take x out of the fraction, hang it out to the side, you've got to have a 1 up here. So we have a negative 1/4, x hanging out to the side. And then the 7/4 does not reduce. Don't turn it into a decimal. And then again, don't forget, when you put these into your graphing function, you need to put those fractions into parentheses. So then go to the graphing function of your calculator and type in the right side only into 2 different y equals on there. So I'm going to do parentheses 1 divided by 2 in parentheses x minus parentheses 1 divided by 2 in parentheses, and then execute or enter. Then for the second equation, parentheses negative 1 divided by 4 in parentheses x plus parentheses 7 divided by 4 in parentheses, and then execute or enter. And then you want to hit your graphing option, and then you should see the 2 lines intersecting. To get your intersection, if you're on a Casio, you need to go to GSolve, and if you're on a TI, you need to go to Second Calc. And you want to find the intersection, so choose the command for intersect. And then on this particular answer, or this particular solution, you get the answer of an x value of 3 and a y value of 1. So because they want the y coordinate, this is the answer we're going to choose. So C is the correct answer. Next question. All right, so in this question it says a water tank is draining at a constant rate. So that's important. So that's something that I'm going to underline or circle. A graph, and it's draining, so it's going down. A graph modeling the volume of the tank V in cubic meters as a function of the time t in seconds that the tank has been draining is shown. So this is where time is. Come on, right? So this is time. And then over here, I'm going to have to move this to the right. So, whoops, over here is going to be your volume, V. So here's how a lot of you might think about this. Since it's a constant rate of drainage, start looking at your graph. After 1 second, I have a volume here of 80. So I'm going to kind of create a little table. So after 1 second, that's an E, so after 1 second, I'm at 80 cubic meters. Okay, so then look at 2 seconds. So at 2 seconds, I'm at, well, it must be 75, right? So write that down. 2 seconds. Whoops, if I can actually spell seconds. Try that again. So at 2 seconds, I'm at 75. So a difference of 1 second, I lost 5 cubic meters. Let's see what happens at 3 seconds. At 3 seconds, I'm at 70. 3 seconds, I'm at 70. So another second has gone by and I've lost 5 cubic meters. So it appears that every second that clicks by, I'm losing 5 cubic meters. So 1 second means I lose 5 cubic meters. The question is, how long will it take the tank to drain? Well, I need to know how full the tank was at the very beginning, and you can tell that by looking at the table. At time 0, I had a tank that was 85 cubic meters. So all I really have to do is take the total volume of the tank, which is 85 cubic meters, and divide it by the number of cubic meters I lose every second. So I'm going to divide it by 5 because that's the number of cubic meters I lose every second. My answer is going to tell me the number of seconds it takes to empty that tank. So if I take 5 and divide it to 85, I end up with 17, and that's going to give me seconds. So how long will it take to drain? 17 seconds. So even though the graph does not show me 17 seconds, I can use the fact that it's a constant change. You can see that every time a second clicks by, I lose 5. That means that I want to figure out how many 5 cubic meters there are in 85. 17. It must take 17 seconds to drain. See, it looks complicated, but it's really not that bad. Next problem. All right, so let's look at these two. Okay, so for question 18 it says, a minor league baseball ticket office sells admission tickets for $5.75 for Wednesday night games. So that would be something important to circle. Whoops, there we go. The ticket office can sell a maximum of 500 tickets. So they have a maximum of 500 tickets. Can't go above that. The function m of t equals 5.75 t represents the amount of money, so m is money, that the ticket office brings in on Wednesday nights, where t is the number of tickets that are sold. So which best describes the domain? Domain would be your x value. Well, in this case, it's your input value. We are inputting the number of tickets sold, right here, t, in order to get m, the amount of money made. So domain is input. So we want to figure out what best describes the ticket sales. So our ticket sales would be all non-negative integers. Non-negative meaning, can you have negative ticket sales? Nope. So all non-negative. You can't have 0 ticket sales, you're not going to make any money. So non-negative implies it's just positive numbers. So positive numbers that are multiples of 575. Well, does that make sense? Seems like it, because we're taking some integer, because you can't sell a partial ticket, a positive integer, and you're going to multiply it by 575. So if I have 10, I'm going to multiply it by 575. If I have 100, I'm going to multiply that amount by 575. So would they be multiples of 575? Here's best how you can see it. So if I sold 1 ticket, that would give me 575. 2 tickets, I would multiply 575 so multiplied by 2, I would get 1150. 3, I would get 1725, and so forth. So those are multiples of 575, because essentially from here to here, from here to here I've added 575. From here to here I've added 575. So this seems like, yes, that's a good answer, but let's read through all the rest. All non-negative integers, positive integers, less than or equal to 500. How see now we're getting a little bit more specific, because here this implies that there is no limit. It says all non-negative integers that are multiples. Well, that could go up to infinity. But remember, we have this restriction that we can't go over 500 tickets. So this one is saying all positive integers that are less than or equal to 500. That's even better. So I changed my answer to B. Let's go on to C. All non-negative rational numbers. Well, a rational number can be a fraction. So since we cannot sell a fraction of a ticket, I am going to have to not accept this one because of rational numbers. So I'm going to put an X through C. And I am putting an X through A because we decided that we liked that part of B better. Okay, then D. All non-negative rational numbers. So again, I'm not even going to read any more of that. So because they're rational numbers, I don't like that, I don't like that, so therefore B has to be the answer. So just read your question. Question 19. Let's see if I can get that moved up. Here we go. All right, so for question 19, it says the graphing calculator screenshot shows the graph of f of x equals negative 1/2 x and the graph of g of x. So don't tell you which is which. Which equation could be used to represent g of x in terms of f of x? Well, if you think about it, I'm going to write f of x right here. Can I get my pointer to come up? It's a little slow. I'm going to write f of x here in slope-intercept form. So remember, our slope-intercept form is y equals mx plus b. So if I write, instead of f of x is our y, so we got that there. And you've got negative 1/2 x, so negative 1/2 is our m, our slope. And then there is no b on this, so technically if there's no b, b is our y-intercept if you remember from our previous question, so b must be 0 for it not to be there. So the only graph of the two that crosses the y-axis at 0 is this one, because this one appears to be negative 1. So just by looking at the graph, I know that this one has to be f of x, and this one has to be g of x. So the question says, which equation could be used to represent g of x? So I'm going to go ahead and take and I'm going to take a look at the difference between the two graphs. The only thing that I see, they appear to be parallel. The only thing I see is that from here to here, we've dropped down the same amount. Okay? In order to go down from one function to another, we would actually have to subtract 2 from the value of the whole function of x. So if we took every output for f of x, meaning your y, and we subtracted 2, we'd end up down here. And so because f of x is our output, x is our input, we're looking at y values, and because we're going down, that is a y value. So the only way to affect y is to take the actual output and subtract 2 from it. So D would have to be our answer here. So for 20, let me make this bigger. Okay. I don't know why that just turned on me, but it did. Okay. So this says, what is the product of this? So I've done a double distribution earlier, so I'm going to go ahead and show this as a box multiplication. just for those who like that better. So I'm going to create a box. It's a 2 by 2. So I'm going to take the 4x minus 2 and I'm going to put 4x here and the minus 2 here. And I'm going to take the 3x plus 5 and put the 3x here and the plus 5 here. So 4x times 3x, essentially I'm taking this 4x and I'm multiplying it to these two and dropping the answers down here. So the 4x times 3x is 12x squared. 4x times 5 is a positive 20, and then tack on the x. Then I'm going to take the negative 2 and multiply it to both of these and drop the answer here. Negative 2 times 3x is negative 6x. Negative 2 times 5 is negative 10. Now the only like terms are these two here. So I end up with 12x squared. 20 and a negative 6, subtract and keep the sign of the larger. You get positive 14x and then minus the 10. So there's my answer. The one that is exact to is answer B. All right, look at question 21. Gary and Jolene are both driving on the freeway at steady rates. So the fact that they're driving at steady rates is important. Gary is driving 40 miles per hour. And Jolene is driving 50 miles per hour. Boy, she's a speeder. Oh, sorry, kilometers per hour. Gary is driving 40 miles per hour. So we'd have to do a little conversion of miles to kilometers or kilometers to miles. So what methods describes a way to compare their speeds? So as I was saying, we'd have to do a conversion, and note that they have given you a conversion that 1 mile is exactly equal to 1.61 kilometers. So would it work to multiply 40 miles per hour? So I'm going to change this 40 miles per hour to an actual fraction. 40 miles per 1 hour. Okay, that's an I for miles. And then it says multiply it by the ratio of 1.61 kilometers, squeeze that in there, over 1 mile. We're looking for, so we're converting on this one, Gary's miles per hour to Jolene's kilometers per hour. So would this work? Well, our miles would cancel, so that's good. And we would be left with kilometers up top and hours on the bottom. That looks good to me. Now, I like this one. So A so far is a possible choice. I'm going to put that in a different color. A so far is a possible choice. Now B looks very similar, except they've switched around this right here. Instead of kilometers over miles, I got miles over kilometers. Here's why that doesn't work. If we change this 40 miles per hour to being 40 miles over 1 hour, and you try to multiply it to 1 mile per kilometer hours, because these are not diagonal to each other, in other words, you cannot cancel the miles, and there's nothing to cancel with the kilometers, it doesn't work. So if you want miles to cancel like they did here, they have to be diagonal to each other. So B is not going to work. So that one's out. For C, we're taking 50 kilometers. And remember, they said select all that apply, so there could be more than one. We have to try all of them. So C, we're taking 50 kilometers per hour, so I'm going to change this instead of per hour to put per 1 hour here. And we're going to multiply it by the ratio of 1.6 kilometers per 1 mile. Are we able to cancel the kilometers here? Nope. Nope. I can't cancel anything. So this is not going to work. So that's not an option. What about the 50 kilometers per hour? So change that to 50 kilometers over 1 hour by the ratio 1 mile over 1.6 kilometers. Now I like this because I can cancel this kilometer and this kilometer. That leaves me miles in the numerator and hours in the denominator. So that one will work. That one's going to convert Jolene's kilometers to Gary's miles, so we can convert, compare miles to miles. So I actually like this one. So I like both of these. So then E and F are interesting. Let's see what would happen. So we're going to multiply 50 kilometers per hour. So I'm going to put per hour here, 1 hour instead of that. We're going to multiply that by 40. Instead of miles per hour, we're going to put miles over 1 hour. Hour. Now, nothing's going to cancel there because nothing's diagonal to each other that can cancel. I can't cancel kilometers and hours, and I can't cancel miles and hours. But, and then multiply that result by this. I'm not sure why I would do that. Well, number one, I still can't cancel kilometers with anything down here. I could cancel miles. So that I could cancel, but notice you'd be left with kilometers times kilometers, which makes it kilometers squared, and that's just not going to work. And that same thing's going to happen with E. So those are not going to, and I'm sorry, the same thing's going to happen with F. But you're going to end up with miles squared. So we really don't want to do that either. So our only answer choices would be A and D. That's the only question on that one. All right, so keep going. Next question. All right, we're almost there. All right, let's make this bigger. Looks like 3 more questions. All right, so question 22. The cost of picking strawberries from Very Nice Farms can be modeled by the function f of x is equal to 3 plus 5x, where x represents the number of pounds of strawberries picked. What does the number 5 most likely represent about the cost of picking strawberries at Very Nice Farms? So remember, we're looking at an equation here where we have a variable term. It changes depending upon whatever x is, and they said x represents the number of pounds of strawberries picked. So we're going to take 5 and multiply it to the number of pounds, and that's a cost. Remember, this whole thing is giving us a cost. And then this is a fixed cost of $3. So they want to know, what does this 5 represent? So what are we multiplying to the number of pounds of strawberries picked? So that's really what we're looking at, and what we're doing with that 5. So could it be the maximum number of buckets of strawberries that can be picked? Well, they didn't mention anything about maximum buckets of strawberries, so I'm going to skip that for a minute. The number of hours it will take to pick strawberries. So 5 hours per pound of strawberry, that seems to be a long time to take to pick 1 pound of strawberries. So I don't think that sounds right. The flat fee charged for picking strawberries, flat fee implies no variation. The flat fee would be $3 here. So that can't be it. That would represent the 3. The price per pound, number of pounds, that makes sense. So the price per pound would be $5 a pound per strawberries. Granted, those are expensive strawberries. However, that is what that must represent. So the answer has got to be, by reason, D. All right, moving on to question 23, second to our last question. Make this a little bit bigger so I can write on it. Okay, so consider the expression, which is an equivalent expression. So we got some very interesting answers like that. What the heck is that? It must be 324 x to the 20 y to the 32. I'm guessing it just didn't print out correctly. This is weird. This is weird. However, you'll see what the possibilities are in a minute. So we've got an index of 4. So if we recall from a previous problem, you were going to take and find the 4th root of 81. So in your calculator, you're going to take 4, and you're going to hit shift, and you're going to hit the caret key because that's going to bring up the X root button, and you're going to put in 81 and then execute or enter. And you will get, if you think about it, 81 is broken into 9 times 9, and that's broken into 3 and 3, and 3 and 3. So what number times itself 4 times gives you 81? That must be 3. Well, the only answer choice that has 3 is here. But why does the x have such an odd exponent? Well, remember, we take that index and divide each of these by 4 and by 4. It just so happens that 5 is not divisible by 4, so we end up with 5/4 as the exponent. 8 is divisible by 4, and 4 goes in there twice, so we get y squared. So oddly enough, A is your answer. Last question. Okay, so Fred writes two functions. F of x is equal to 5x, and g of x is equal to 5 to the x. Okay, this question I inadvertently gave you. They're not going to ask you this question on the EOC. Do not worry about question 24. Yippee skippy. And the reason why I say that is because of this right there. You don't know what to do with variable exponents. Have a fantastic rest of your day.